well, welcome to spotter training for 2017. Really good turnout tonight. That's really good to see. Who in this room is here for the first time? Never been to a spotter class? Wow. Okay, that's very typical of this year so far. We've taught, I don't know, almost 20 spotter classes already, and we usually average about 30% of the folks are new. This year we're getting closer to 40 to 50%. That's great. Wonderful. Good to see a lot of new faces, a lot of familiar faces also, so that's really good to see. All right, let's go ahead and get started. So, like I said, welcome to spotter training. Severe storm spotting, it's got everything. It can be pretty challenging. If some of you were out today looking at a few things, this wasn't a really, good event that's like, textbook or anything, but it was a little challenging. It can be exciting, but also dangerous. You have to really be careful when you're out there. So we're going to talk a lot about that, especially in the second part about safety, and it's very timely as well. Some of you may have already heard, but if not, 2 days ago there were 3 experienced storm chasers that were killed in Texas. It was a traffic accident. They didn't get killed by the weather. One of them ran a stop sign and T-boned the other one, and all 3 were killed. 2 were very experienced chasers, one of the guys I knew. So, this is, it can be very dangerous. You have to be careful when you're out there. Because Steve Hilberg was telling me this earlier, it was so, today the rain was coming down so hard that visibility was almost zero for a moment, and that's just the kind of weather that you're going to be dealing with at times. It can also be time consuming. Sometimes we put that watch out there and we're waiting for things to start developing, and we're waiting, and then finally everything breaks and we get the weather, but it can take some time. But most of all, it's very rewarding, because what you're doing is you are helping the people in your community, but also surrounding communities. The information that we're getting from the spotters here in Champaign County, we are sharing with the folks in Vermilion County and Ford and Iroquois County. And then we're getting calls from the National Weather Service in Indianapolis saying, what are those storms doing? What did they do when they were in eastern Illinois? Because they're trying to make warning decisions for western Indiana. So it is very, very rewarding. We say this all the time, and we really mean it. Storm spotters are the most important partners that we have when it comes to the whole warning process for high impact severe weather. And the result is potentially life-saving messages. But what we have found out, and our agency, National Weather Service, has worked a lot with sociologists and talked to people who have been in severe weather instances, and in a lot of cases, people will not respond to warnings favorably, which means going to shelter, unless that report says that a trained storm spotter or law enforcement or some public official has verified that something has occurred with that storm. People don't want to listen to Doppler radar indicated a rotation, even though the radar is very good and it's giving us some awesome information, particularly at night, but people want that human interaction, that human verification. So timely spotter reports are very critical to warning operations. So we're going to start with the basics. Thunderstorm development. For those of you that are new, we're going to give you the bottom line as to what it takes to get a thunderstorm to develop. The next thing we'll go into is storms come in all shapes and sizes, so we're going to talk about the different types of thunderstorms, especially those that we are familiar with here in the state of Illinois, because there are some types of thunderstorms that we just don't get here because of our geography. And then we'll spend quite a bit of time talking about supercells. These are the worst of the worst. These are the highest, they produce the highest impacts. They produce the worst severe weather as far as wind damage, long track tornadoes, the largest hail. So we're going to spend some time talking about those. Our agency is not printing any of the spotter booklets like we've had in the past. We don't have the money in the budget to do it this year. So instead, we have this locally designed, beautiful color handout we have enough for everybody here. And This is going to have a lot of the web pages on it because in the second part, we're going to talk about a lot of resources that are available to you, something that we haven't done a whole lot of in spotter training in the past. So we're going to talk about some of those resources, where to get them. Don't feverishly try to write down all the web pages. They're all right here on this handout. We got a hail size chart and safety reminders, so make sure you grab one of these. I got hundreds of those, so we got enough for everybody. All right, so let's jump right into it, thunderstorm development. First of all, let's set the stage here. There are more severe thunderstorms and tornadoes in the United States than any other country in the world. In a typical year in the United States, we averaged 1,300 tornadoes, roughly. It's like 1,280 something every year. Last year was a real quiet year. We only had about 900 in the US. This year, we're starting to pick up quite a few already. The next closest country to us is Canada. As far as tornadoes, they get about 100 every year. That's it. We are number one every year in the United States for tornadoes. There's no other country like that. And if we look at tornadoes as far as per square mile, Illinois ranks 5th in the country for the most tornadoes per square mile since 1950. Kansas is number one, no surprise there. Florida, they get quite a few tornadoes, particularly wintertime and then from tropical storms. Oklahoma, again, no surprise there. Iowa, and then Illinois. You don't see Nebraska, you don't see Texas. We are in Tornado Alley when you look at it from the standpoint of tornadoes per square mile. So that raises the question, why? Why do we get so many tornadoes in the United States, especially here in the Midwest? Well, it's all about our geography. The geography of our country, the climate that we have. In order to get the ingredients to get a severe thunderstorm and get a tornado, which we'll talk about here in the next few moments, you have to have certain things available to you, moisture, etc. And a lot of that is available to us because of our geography. The Gulf of Mexico providing a lot of moisture for us. That's not the only source, but that's one of the main sources. Plus you've got the Rocky Mountains out to the west, the much smaller but still Appalachians in the east. And a lot of that warm, moist air funnels up right into the middle part of the country. And combine the other ingredients with that, and you get the recipe for severe storms and tornadoes. There's no other place like this. Possibly parts of Canada in their plains, and also parts of China have similar setup like this, but nothing at all like we do here. So first of all, let's go ahead and make a thunderstorm. Because to be able to get severe weather, you need to have a thunderstorm. So the first ingredient we're going to talk about here is moisture. Now, the video that's showing on the right side over there, and this is a rear projection here, so I can't use my laser pointer here, so I'm going to use my little handy dandy mouse here. But the storm over here that started out circled in this time-lapse video, that is going to become a severe thunderstorm with time, because all these ingredients are available. First ingredient is moisture. Gulf of Mexico, as I already mentioned, is the leading source of moisture, but also local vegetation. We can draw a lot of moisture from the grasses, the trees, the types of crops that are grown here and in surrounding states. Then we need to take that air and we have to lift it. We have to have some way of pushing that air up. The warm, moist air needs to go up. Well, fronts that you would see on a weather map, cold front, warm front, those are all pushing masses of air, whether it's warm air coming up from the south like we had today. We had warm air in southern Illinois that was pushing its way up here into central and eastern Illinois. Cold front, which will be coming through a little bit later if it hasn't already. That is cold air that pushes the warm air out of the way, and that forces the warm air to rise. You can also get air to rise when you have the jet stream, which is a band of high winds, roughly about 5 miles above the ground, moving along. That causes air to rise when the jet stream is near the area. Heating of the ground is another way. And a lot of people who start out spotter training think that's the only way. Or if you talk to people in the public, they'll say, oh, at night you don't get severe storms because the sun sets and you don't have the heating anymore. That's only one way to lift. You don't necessarily need that. If you got warm air and one of these other things going on, you can get severe storms in the middle of the night. Something called an outflow boundary, which is basically the cool air that pushes out away from a thunderstorm, the rain that the thunderstorm produces. And that can cause other thunderstorms to develop or cause air to rapidly rise. So those are the main ways. There are other ways, but around here, these are the main ways that we get lift. The last ingredient is instability. This ingredient here can sometimes be difficult to try to grasp or try to explain. So we're going to use the illustration of our hot air balloon to describe instability. The atmosphere is unstable, or instability is present when air can move up and down, not just up, but up and down with very little forcing, very easily. It can move up and down within that cloud, within that storm. So like this video shows, we start out kind of stable, and look at the cloud on the right side. Look how rapidly it erupts. Now granted, that is a time lapse, but look how quickly that storm goes up. That is an unstable atmosphere. That means once that moist, warm air got a push up, it just keeps going until it reaches a level in the atmosphere that will basically stop it from going higher up where it's more stable. So it'll spread out. Like you can see with the upper clouds there, we call it the anvil cloud. You can see how it has spread out up at the top here, right in there. The atmosphere is stable, so the opposite of instability, when air is moving a little bit, but really not very much. It gets a push, and then it starts to go up, and then it stops. And then it just kind of hovers around in the same place, up and down, but very little vertical growth there. So the up and down movement is very restricted. And we see clouds like this. We would call these fair weather cumulus clouds. So no instability present on days like that. So those are the three main ingredients you need to create a thunderstorm. If you're missing one of those things, then you're not going to get thunderstorms. You might get some light rain showers, but you're not going to get that thunderstorm. The reason this is important is because unstable air will result in the rapid upward motion like we talked about, and it's important for spotters to know where to find where that air is going up, or the updraft. You can see where that arrow is there going up through the storm, but look at the bottom part of the storm here. You don't have any rain falling through that area, okay? We call that the updraft area. It's important to find the updraft because most tornadoes are going to form in that updraft area. You need to have rapidly upward moving air for a tornado to develop. It also, the upward moving air, allows precipitation to form higher up in the storm. And then, while we still have unstable air in the area, the cold air from the rain and the cloud sinks, the heavy rain and the hail comes down with gusty winds, and we call that the downdraft. Okay, we were experiencing several downdrafts this afternoon. This is what's going to give you those high wind speeds when the momentum of that air coming down through that storm. There are other things within that storm, higher winds at certain levels above the ground that can also come down, but you have to have an environment where that air can come down and reach all the way to the ground in order to get that strong wind gust. Or it'll just stay above the ground and it won't reach down and you won't have much wind out of that storm. So this is what unstable air does for a storm. Rapidly rising air creates the precipitation. Precipitation cools, condenses, or cools and condenses. You get the precipitation, then it falls through the storm, comes down through, and brings some wind and cooler air with it. This ingredient is kind of the wild card in a lot of this, wind shear. Wind shear is, what it means is when you go up in the atmosphere, the wind is going to increase in speed as you go up or change direction as you go up, and sometimes both, okay? Today we had a lot of wind increasing with speed as we went up. Very little change in direction. There was a little bit, but not very much. But it was enough to allow the storms to become severe. So that's what we mean by wind shear. This can make the difference between a severe thunderstorm that might barely produce a wind gust or just produce some hail, versus the type of severe storm that could be producing long track tornadoes or a lot of downbursts, which are high wind gusts that can produce damage. This is a video here showing wind shear. It's a time lapse, but what I want you to notice, the low clouds. Notice how they're moving kind of in toward the video, and the upper clouds, the whiter ones, are moving from left to right. And you can see that as those clouds are moving from different directions, that sets up an environment characterized by wind shear. And sometimes you don't even need time lapse to see that. If you've got very high winds right at the lowest cloud level, a couple thousand feet above the ground, you can see the clouds coming from one direction, and then above that, clouds coming sometimes from completely the opposite direction. That's pretty extreme, but when you have that, that just means you have the directional shear, the wind shear coming from different directions, and the speeds are probably a little bit faster as well as you go up. So what that does for you with strong wind shear is you start to get this horizontal rotation like it shows in the picture over there. Imagine if you had, say, an empty roll of paper towel, you just had the cardboard roll, and you pushed at it, the top and the bottom, at opposite directions to characterize the wind coming from opposite directions. It's going to start rolling, okay? That's what the atmosphere does. It will roll horizontally, kind of gradually. It's not like you're going to see it spinning like this, but it will gradually roll with wind shear like that. Now, this is before the storms even get there. Now, as a storm approaches, and the storm has an updraft, the air moving up in the storm, it'll pull some of that horizontally rotating air up into the vertical. And you'll get this horizontal rotation kind of bent like this. And with time, what'll happen is the entire updraft will start rotating. That's what we call a mesocyclone, or a rotating updraft. We'll talk about those more when we discuss the supercells. But this is what is important for the supercells to be able to produce a tornado or severe weather. When I say severe weather, I mean also large hail and damaging winds in a supercell. So this is what strong wind shear can do for you. The horizontally rotating air pulled up into the vertical by an updraft from a storm that approaches that type of environment, and now that updraft is rotating. Okay, some other features to point out, and this would be for storms that are at a distance. So they're not right on top of you, but we're talking about maybe 10 miles, 30 miles. I've even seen some of these features with storms 60 to 80 miles away with good enough visibility. First thing here at the very top is this overshooting top right here. That part right there, remember I said how the thunderstorm, the updraft goes up and then it hits a more stable layer in the atmosphere and it spreads out and creates that anvil cloud? Well, sometimes the updraft is so strong, it punches right through that area where, which is supposed to resist upward motion, and it keeps going for a little ways. When you see that, that means you have an intense updraft. The air moving up within that storm is going up very high rate of speeds. If the top is there for several minutes, usually about 10 minutes or more, the storm is strengthening. And then if you watch that and you see it actually collapse down, you'll see it disappear, meaning it's collapsing down. Severe weather is imminent. Downbursts, and sometimes we even see tornadoes develop right after that overshooting top starts to collapse. So again, it's not something that's imminent for your area, but it gives you an idea of the storms that might be approaching, what they're doing, what type of environment you have. The anvil cloud I talked about, particularly if it spreads back toward the west. So we're going to assume here that we're looking north or northwest at this storm here. And if the anvil cloud goes back west, that's important because it's opposing the wind flow. The upper level wind flow would be going from left to right in this picture. And if that anvil is spreading back toward, into the wind, then again, it has a very intense updraft to be able to cause that to happen. And then take a look at the storm tower here. This is the part of the storm right in here. That's the part of the storm right in here where the updraft is and where it's the strongest. And because it's going up so rapidly, it's going to create these clouds that look like clusters of cauliflower. A lot of bulges on the clouds. They're not smooth edges, but they have very rough edges to them, very distinct edges. That is a sign of a very strong updraft and a severe storm. And sometimes you can see, if you follow if the storm's close enough, if you can follow where the lower part of the storm is and draw a line up to the overshooting top, a lot of times you'll see it tilted. And that's because of the wind shear. The wind is higher speed at the upper part of the storm, and it's actually causing that storm to kind of be tilted over a little bit. That's what will help that storm to persist for several hours. As the storm gets closer, now we see the lower part of the storm is really what we want to pay attention to here. We still see the other features. Over here you still have your clusters of cloud in here with the sharp edges. You've got the edges on the anvil here. Again, not very fuzzy looking, but sharp back toward the west. But we want to look to the bottom part of the storm here. We'll talk a lot more about these when we get into supercells, but these low-hanging clouds called wall clouds. Again, that is where the updraft is, but that's a lowering of that rotating updraft, and it's often in or near that wall cloud that tells you, that's your clue, your visual clue. I've got rotation in the lower part of the storm if the wall cloud is rotating. Some don't rotate, but keep an eye on it. If it's rotating, then you want to watch that for a location for a tornado to develop, right near that area under that wall cloud. But we'll see a lot more pictures of those here coming up. So as kind of a side-by-side comparison, weak storm on the left, you can see how the anvil cloud is really fuzzy and spread out more horizontally. Doesn't have real sharp edges like the one on the right does. This also has the overshooting top on it where this one doesn't. The clouds within here, a couple of the clouds lower have these, like it looks like those clusters of cauliflower in there, but they're generally softer edges as compared to this one, which is a more stout tower with much sharper edges. So this storm here has very weak updraft, limited instability. The wind shear is pretty weak, where this is just the opposite. It has all the ingredients. The updraft is strong. There's plenty of instability there to keep that storm going, and the wind shear is going to be a contributing factor for severe weather or possibly tornadoes. So let's jump into the different types of thunderstorms, from the most basic to the supercells. The most basic storm we get is a single cell thunderstorm. These are your storms that last for roughly 30 minutes to 45 is about the average for these storms. This is your typical summertime type, one pops up here, one pops up there type of storm. They can produce some very heavy rain because they have a lot of moisture with them. But because the wind shear is really non-existent, they move very slowly. The updraft goes straight up. The rain and the precipitation develops and falls right through the updraft, cuts it off. That storm dies in a relatively short period of time. Multi-cell clusters are basically a cluster or a bunch of storms, usually along some type of front. Stationary front, you can get them near warm fronts, or as it says there on the outflows of nearby other thunderstorms. And it's a cluster or several thunderstorms. They're all grouped together, and they're all going through different stages of the thunderstorm life cycle. The biggest threat with these is the heavy rain, because again, wind shear is kind of weak in these storms. They develop along this front, and they keep developing along the same front that doesn't move very much. And so as the storms track along the front, it's almost like a train going on the tracks. The storms are just going to keep moving over the same area, and the same areas are going to keep getting heavy rain. I remember one, gosh, it was over probably 10, 12 years ago now, southern part of Champaign County got one like this and ended up with over 10 inches of rain one afternoon from these multi-cell cluster storms. Once in a while you can get tornadoes out of these. We'll point that out here in a moment. If you get a strong enough updraft in a storm, and sometimes in a newly developing, not even a thunderstorm yet, you can get a type of tornado out of that, but they're usually short-lived, pretty weak, and they don't last too long or travel very far. But these do produce quite a few downbursts of wind. We get, here in Illinois, we get wet downbursts. In the high plains you can get the dry ones, but here ours are almost always wet. Meaning, like it shows in this video here, you see this column of heavy rain right here is coming down, impacting the ground, and when it does, it pushes out, and your highest wind speeds are right here. And you can see how it's kind of curled up in this video on the leading edge there. Here, we'll just play that again. So these can go on for several minutes. They can produce very high wind gusts. They can be fairly wide. Sometimes they're narrow. We call those microbursts. But some of them can be pretty wide too. I've seen them, 2 miles wide or greater, and continue on for about 5-6 miles in one direction with very high wind speeds. That rain foot on the leading edge should be your visual clue as a spotter that storm up ahead, I'm looking at that storm, there are some high wind gusts right in that area down the road from where Andrew took these pictures. Wind speeds, generally 60 to 80 miles per hour on average. We saw quite a bit of that this afternoon. The highest wind gusts we had were right in the 60 to 70 range. I have seen downbursts. We had one in Lincoln actually about 13 years ago where there were winds measured at over 120 miles per hour out of a very wide. The downburst was almost 2 miles wide. Took roofs off houses, destroyed garages, knocked a lot of trees and power lines and power poles down. So they can produce quite a bit of damage. Just because there's extreme damage to something, especially outbuildings, it doesn't necessarily mean it had to be a tornado, especially if the path is pretty wide and it wasn't accompanied by any rotation. So here's a video showing, in time lapse again, multi-cell clusters. And I'll let this play through a couple times. The thing I want to point out here is on the right side of the screen here, this would be in the easterly direction. These are where the storms are dying out as they go through the life cycle. And the formation, the newer storms here are on the left. And you can see how and he zooms out a little bit here too, you can see as the storms die out, the clouds are much fuzzier. The one with the tallest top here is your strongest storm, and here are the new ones in the flanking line here that just keep developing. So again, here's your strongest storm, it weakens, this becomes the strongest storm here. Now this updraft takes over, that dies out, this updraft takes over, eventually it's going to flatten out and move off to the east, and then that one. Now we have this one, and you can see how these storms are just clustered together. It's almost like they're taking their turn as they go through the line, in this case from east to west with this time-lapse video. So this is what a multi-cell cluster storm would look like. This is more than just, some people might look at this and go, wow, that's one big, look at that big thunderstorm. That's actually a cluster of about 4, 5, 6 individual thunderstorms, okay? Now, I always tell spotters, there's so much information out there, so use whatever information is available, including if you can get radar sources, because that can really tell you a lot of what you're looking at. And some of you may already have some, but if not, if you're going to be a spotter, get a good radar app on your phone. Because a lot of the good radar apps now, what they'll do is it'll plot your position if you got location turned on your phone, and then you can see where you are relative to the storms. So it's a safety thing, but also it gives you a perspective as to what you're looking at. This is something that, 5, 10 years ago, spotters didn't have that unless you were dragging a laptop along with you, which was really not the best thing to do. got kind of cumbersome. But at any rate, here's a cluster of thunderstorms, multi-cell storms. They developed, they developed along a front, which was kind of west-northwest to east-southeast. There were actually, cell number 1 is off the picture here. It was dying out. Cell number 2 is going through the dying stages, and 3 was the strongest storm, but it's producing some heavy rain. Cell 4 is now the strongest storm, and then this, which has just developed and starting to get organized, and probably another one off over here. This one over here is not quite in the thunderstorm stage yet. However, you can see from the descriptions there, the strongest storm, that could produce anything. It's got the heavy rain, the downbursts, the hail. You could also get some weaker tornadoes that might develop near the updraft area. Let's say if your inflow is coming from the south here, somewhere in this area here, you could get a weak tornado that would develop. You could also get a tornado developing with this very weak storm right over here. Those kind of act like what we call landspout type tornadoes. In fact, I'll show you a few images of these. The thing about these is they form simply because they're developing along a front, and because, especially if you have a stationary front, you have wind coming from the opposite direction. So you have a wind from the surface coming up, let's say, from the south, and on the other side of the front, the wind is coming from the north or northwest, and now you're along that front. You're getting that horizontal type rotation. When you start to get that cloud first forming and the updraft is increasing in intensity, it's going to pull some of that horizontal rotation, like I talked about before, into the vertical and stretch it, and you're going to get these thin, ropey looking kind of tornadoes. The thing about these is there's no pre-existing rotation up in the storm or up in that cloud. So you're not going to see a funnel cloud. It won't have a wall cloud with it. You'll just suddenly see these thin tornadoes that start developing. And we're not going to see any rotation on radar, or you won't either if you have a radar app looking at the velocity of that. So you just have to be cognizant that there's a front nearby and that these could develop. They can be nearly transparent. I mean, they're still tornadoes. They're still rotating fairly quickly in there. They can produce, EF0 to EF1 type damage. So you're talking wind speeds could exceed 100 miles per hour in the rotation there. They usually move very slowly. These things are usually creeping along about 5 miles an hour. Sometimes they're even stationary. You might see them get up to 10 miles an hour, but usually not that fast. They often form with this very weak or first developing storm on the southwest end or west end of a multi-cell cluster. This is an actual example. I talked about that day that southern Champaign County, northern Douglas County had 10 inches of rain one afternoon. This was that day. This was May, I can't remember what year it was. It was late May. And there was a stationary front through here, and the storms just kept rolling across this area, but within this oval here. So roughly from Moultrie County across Douglas, southern Champaign, and part of Piatt County, there were 9 tornadoes that developed in that area in less than 2 hours along that front. Every time one of those little tiny rain showers was just starting to develop, it pulls some of that horizontally rotating air in the vertical, and we'd get a tornado. In fact, north of Tuscola, there's a picture somebody took of 3 of them on the ground at the same time from 3 different updrafts that pulled those up. What we've seen is that these typically develop a lot from late April into June. We don't see a lot of these in the heat of the summer or during the cool season. We're still trying to figure out why that is, but we see a lot of these from late April, May, and into June. Some of it could be because of multi-cell cluster storms being more prevalent during the spring into early summer. I think some of it might also have to do with the fact that it's so dependent on the opposite wind flow near a stationary front. You don't get a lot of stationary fronts hanging around in summer, but if you did, you've got a lot of difference in low-level flow friction as the crops are growing up taller. And you got some fields with beans, some with corns, and so the wind is just it's not going smoothly across a flat area like it would when the crops are almost nothing. So that could be part of it as well. But typically we see these late April into June. And like it says here, we got to get the spotter reports on these because we don't know that they're there. We're not going to see any rotation on radar. This was about 15 miles north of Bloomington, Illinois, 3 years ago. I like how it's kind of lifting off the ground here just as it's getting ready to dissipate. Now that one fortunately was out in open fields. It did no damage to any structures, didn't injure any people. Tore up the ground a little bit in those fields, but didn't damage any structures. And it was there for almost 10 minutes. So the next thing we're going to move on to here is squall lines. And squall lines, they're kind of a cousin of the multi-cell clusters, but rather than having these clusters all kind of going up seemingly independently, but they are going up in some type of fashion. With squall lines, these are developing in a more uniform fashion, usually ahead of a cold front. As the cold front moves into the area, the southeast winds or easterly winds ahead of it will rapidly rise up and create these lines of storms, which can extend hundreds of miles. And we'll show you some examples here when we look at some radar images. But the main factor with these is the damaging wind. This is your classic straight line wind type of storm. You can get tornadoes out of these. We'll point that out when we look at a few images here and when we combine that with radar. They usually move fairly quickly, so you don't often get very heavy rain out of these. You can get a brief, very brief downpour right when the storm first approaches. And then you can get some hail out of these, but that's not usually the main show here. The main show is going to be your wind. The leading edge of a squall line is marked by this cloud. We call it a shelf cloud. And when the squall line approaches your area, you will see this shelf cloud extend across the whole horizon typically. Some things to look for, some visual clues here. Well, first of all, we remember from spotter training that the updraft is in the area where there's very little rain or no rain. So that should be on the leading edge as the storm is approaching. So the updraft inflow is right on the leading edge out ahead of the storm. The downdraft, that's the area where the high wind and the rain is with the storm. Remember when we talked about how tornadoes develop in the updraft. So if the tornadoes are going to develop, they're typically going to be right here on the leading edge as the storm approaches, okay? So let's take a look at it. Let's compare some shelf clouds here. These are all shelf clouds that produce severe weather. This one is from northern Champaign County, August of 2012. Really nice looking shelf cloud on the leading edge here. The thing I want to point out here is notice right here where I'm kind of moving the mouse along here, you have wavy looking clouds above that. You got one area here, here, here. This is from the fact that this line of storms is moving so fast that that updraft is rapidly rising up on the leading edge. So the faster it's moving, like pushing, it's almost like a snowplow pushing the snow out of the way really fast. It's pushing the warm, moist air up really fast. So the faster it moves, the deeper those clouds are, the more wavy they look. And that's a visual clue to you as a spotter that that storm is going to have very high wind gusts with it. Here's another one. Taken in southern McLean County a couple years ago. Again, a leading edge of the shelf cloud here. Notice these tiers or waves of clouds above it. That's indicating, again, that the updraft is moving up at a very high rate of speed. Next one is my favorite picture. Love this. From Canada, our neighbors to the north up in Saskatchewan. They had wind gusts up to 80 miles an hour with this storm. Several interesting features with this. Nice looking low hanging shelf cloud. Notice again the lines, wavy clouds above. A lot of what we would call shark's teeth hanging down on the front edge over here. You got to watch those because remember, tornadoes can develop on the leading edge of a squall line. That could be one favored area there. Probably a more favored area though is where, see how it kind of curves around right here? I'd be watching that area right there to see if anything were to develop very quickly on the leading edge with the tornado. And then all this dark area here, that's the heavy rain, because with these, the heaviest rain is right at the front. You go from no rain to suddenly you're in a sheet, a downpour. And some of the storms today kind of exhibited that as well. And then the rain lightens up usually after a few minutes. Not like the downbursts. Those downbursts, you know, with the multi-cell clusters and the downbursts created by supercells, those things can go on for 10 minutes or more. Typically, these will move along, so your heaviest rain isn't going to last quite that long. But you can still get some pretty decent wind gusts out of these for quite a while. But the strongest winds are usually right at the leading edge here. Now let's take a look at some shelf clouds that with storms, lines of storms that were not severe. Here's one from Logan County around Mount Pulaski, southeast part of the county last year. A little bit of wavy looking cloud here, but it's really kind of a mess. And the shelf cloud here is really not very well defined. You don't have a lot of structure there. Wind gusts maybe up to 40 miles an hour. Here's more typical of what a non-severe shelf cloud would look like. Very, again, low-hanging cloud on the leading edge, but you don't have those lines, those wavy clouds above it. So it's moving quite a bit slower. This one here was close. We got 50 mile an hour winds out of this one north of Bloomington near El Paso. And you did have some of the interesting low-hanging clouds on the front end as well. This one would definitely bear watching because she had 50 mile an hour winds out of this, but 10 more miles an hour and you're starting to knock over some tree limbs and shallow rooted trees. So this one is very close, but again, it just didn't quite have the structure aloft. And you can see, especially up here in the upper part of the storm, where the clouds are not quite as deep. They don't go all the way up. It's a pretty shallow storm. So these are some of the visual clues that you can use when squall lines are coming through. But remember, I said try to combine radar with what you're seeing out there when you're spotting these storms. Here was a day, July 13th of last year. A lot of wind gusts across large part of central Illinois and western Illinois. Winds up to 90 miles an hour in a few places with this line of storms. We had one of my coworkers up here in the southwest part of McLean County around 5 o'clock. He was up in that area. And the thing that we note here was watch how some storms just east of Springfield developed right there, and they merged with the line as it was approaching. Well, right where they merged, he happened to be there and took a picture of that. And to point this out, there's one line coming up from the south. There's the line coming from the west. And here's where the two merged right there. Okay, and he was right. It was just perfect timing. I'll say too that the guy who took this picture, he loves to photograph storms. He's not a meteorologist. He's one of our electronics specialists, but he's learning some stuff along the way. And he said, the reason I took the picture is it just looked kind of cool. Okay, I said, Mark, you did an awesome job. All of us at the office were like, oh my God, did you see that picture? That's amazing. That's going in next year's spotter class. So he's never even been to a spotter class, so he wasn't quite sure even what he took a picture of. But he kept taking pictures, and almost 5 minutes later, he caught that. The merged storms caused a weak rotation. And so now we got a lowering, and so I went back and I looked at radar data, archived radar data, and I was like, oh my gosh, right near where he was, we had a rotation here. The green is wind coming toward the radar, and Lincoln is down here. So Wind toward the radar. Red is wind going away from the radar, so we had some bright green and bright red. A little bit of a rotation right there. His position is here. He's looking to the west-northwest, and he catches that. 10 minutes after he took that picture, and he got out of there because it started to get really windy, and he thought, okay, I don't want to get caught in this thing. But northeast of, or north of Hayworth, up in the central part of McLean County, they ended up with 1.5 inches hail and 70-mile-an-hour winds after that merger. So I guess here's the bottom line is, again, combining what you're looking at with your eyes with what radar can show you, seeing those merging storms. And that's very typical. When we see storms merge like that, they will often produce severe weather a few moments later. And in this case, it was about 10 minutes or so after they merged. You know, use as many things as you have at your disposal. There are favored areas and squall lines for high winds. Again, this was something that we saw quite a bit of this afternoon, where these segments of the line kind of bulge out more than the rest of the line. That's where your highest winds will be. There are favored locations for tornadoes as well. Those tend to be where you see breaks in the line, like here around the Quad Cities, a little kink or break in the line here, and back down over here, southwest of Peoria on this particular day. The other thing is, if it's really surging out, pushing out, and you've got this, we call it a bow echo, right near where it's bowing out the most, you can get tornadoes that rapidly spin up in that area too. So again, it really helps to combine radar with what you're looking at. And this particular day, a lot of trees and power lines blown down. This was middle of November 2015. In fact, there were two right here near the Quad Cities, 2 miles east of Moline. There were a couple of tornadoes that developed with this break in the line here. So that's just where you get that kinks or the breaks because you get rotations along the line. And they actually are mesocyclones. It is a rotating updraft in that area. Okay, let's go to supercells. Let's talk about these things and the tornadoes they produce. Here, our threat level is pegged all the way to the right for everything: wind, hail, heavy rain, tornadoes. These are the worst of the worst. The other thing with these is when you typically have the big hail, I'm talking about like golf ball size or larger than golf ball size, you have to have an intense updraft to be able to sustain hail that big for that long before it hits the ground. So if you have hail that large, you are dealing with a rotating updraft. You have a supercell or a supercell that's embedded in a line of storms. But there are different variations of supercells. I'm going to talk about two of them, the two that we typically see more of around here. The classic supercell, these are the ones that produce the long track tornadoes. Think of the Washington tornado from November of 2013. That tornado was on the ground for 50 miles. We had a few this year already on February 28th. There were several tornadoes that had tracks of 20 miles or longer throughout the state of Illinois. These tornadoes are typically easier to see. Then there's the high precipitation supercells. A lot of these tend to occur east of the Mississippi River generally. The rotation, there is rotation there. You have inflow, you have an updraft, but the rotation can be very difficult for storm spotters to see because of where it's located, and we'll show you some examples of those. Think of that same day, November 17th, 2013, but the Gifford tornado here in Champaign County. That was a high precipitation supercell. Started out, a lot of those storms started out as classic supercells, and then they evolved into high precipitation supercells, and we see that a lot. They don't always just stay as one type. They can, as they move across the state in different environments, they can evolve from one to the other. So the characteristics that you know you're dealing with a supercell. Well, for one thing, they're very organized, long-lived storms. The key, though, is that the updrafts rotate. Okay, if you've got a rotating updraft, rotation on radar, then with an individual storm, then you're dealing with a supercell. The rotating updraft, we give that a name. We call it a mesocyclone. Don't worry about the name if you don't remember that, or we call it meso for short, but just know that the updrafts rotate within these storms. Now, if you look at this classic supercell, and it's got kind of this banded look to the clouds here, it's like, hey, wait a minute, that looks a lot like those squall lines you were showing me. The difference here is that's an individual storm. It's not spread out across the horizon, approaching, from, where the whole south or western horizon is full of that storm as it's approaching. But the bands there indicate the rotation that's going on within that. This whole updraft here is gently rotating because it's so broad across. They average about 2 to 3 miles across. I've seen really big ones, or we've seen ones less than a mile across. But generally they're a couple miles across, and it's hard to see that rotation with the naked eye. It's not like a funnel cloud that's spinning like a top. It's more of a left to right counterclockwise motion. And then with the high precipitation supercell, you see a lot of the same thing, the banded nature indicating the rotation, but the difference is there's this shield of rain right here that will be between you, if you're to the south of the storm, between you and the rotation. We'll show why that is here in a moment. But some of the visual clues, especially with a classic supercell, a wall cloud is a persistent, and the key is the word persistent. Because if you truly have a wall cloud, it will be there for several minutes. Usually it's in that rain-free base area. So in other words, it's the lowered area. The updraft is right in that area. The storm, all the air is flowing into that and going up into the storm. The key is the rotation. Once in a while, we see some wall clouds that don't rotate. It's the lowering, and either it doesn't rotate or they rotate so slowly that it's difficult to see if there is rotation. But those typically don't last quite as long. You'll see many times upward motion present within this. You may even see like dirt or debris, if it's been dry lately, actually getting drawn right up into there. And once in a while, these will have these tail clouds too. That's just kind of an indication that, yes, definitely that is a wall cloud. And it's drawing some of the moisture that the rain is producing and all the moisture that's feeding the storm, rising rapidly in that updraft, and it creates that tail on the cloud there. Here is the storm in southeast Champaign County from near Homer last year, September 9th. Video from Brad here showing the tail cloud here. So you have all this inflow coming up into here, all the moisture feeding this. It's very close. He was pretty close to this, and so it looks large across here. And it was a pretty large mesocyclone here, but you've got the wall cloud here toward the left of where that inflow is there. And a few moments, I guess it was about 6 minutes after this portion of the video, is when that tornado developed and moved on to the northeast to south of Homer. Some more images of wall clouds. These typically wall clouds are they're very distinct lowerings. Sometimes they just may appear as little bumps on the bottom, but a lot of times they're very distinct. And just kind of a general rule of thumb here too, if we consider this kind of the base of the thunderstorm, and if it's extended that low, more than halfway to the ground, it's not going to take much for a tornado to develop near that. So that's a classic type of setup right there. Here's one Paul Hadfield took last year in Montgomery County near Raymond. Very distinct tail cloud on this storm. Very obvious picking out this wall cloud, and it was rotating pretty good there. A few minutes later, the funnel cloud developed as it got closer to him, and a couple minutes after this photo was taken, very brief tornado development with this storm, with this funnel cloud. Didn't do any damage, quick touchdown of that tornado near Raymond. Here's one from south of Dalton City in Moultrie County a year ago in May. A very distinct wall cloud here, tail cloud on the end, on this side here. Very low to the ground. This one here most likely should have produced a tornado, but there was something missing that didn't allow this tornado to actually form with this wall cloud. But it was rotating, it was there persistent for several minutes, and then dissipated without producing a tornado. So when we're looking at classic supercells, again, we're mixing radar with what we're looking at. Here's the tornado that was near Rochelle, Illinois, a couple years ago. Produced the Fairdale EF4 tornado. Thing to point out here with the radar imagery is with a classic supercell, you have your precipitation shield pointing in the direction the storm is moving. So in this case, to the northeast. All this red, for those of you that aren't familiar with looking at radar, all the yellow and red in here is this moderate to very heavy rain and hail in the storm. This is the core of the storm. This is your downdraft area. You can get high wind underneath that as well. We call that the forward flank downdraft here, right in this area here. And you can get there was some pretty large hail with this storm. I don't remember the size of the hail, but it was quite large. And then typically what you'll see is the rotation here will be right around on, in this case, the southern part of the storm, southwestern part. This is where the updraft is. The air was, you can see the surface observations here. We had winds of, 28 knots or, over 30 miles an hour feeding this storm from the southeast. And the rotation was right in this area here. Now at this point, the tornado, as you can see here by this image, the tornado was already on the ground. And what we're seeing here, the red, was the debris. Call that the debris ball. The tornado was picking up the debris from the fields. It had already done some damage to some properties north of Rochelle. So that's what we were seeing on the radar. But before there's debris, we typically see kind of this thin hook, usually like a kind of a appendage hanging below the storm, or a backwards J, on radar here. That we call that a hook echo. And you see that's an indication of that rotating updraft that's associated with that storm. So this is a textbook case of a classic supercell. So when we're going through the tornado life cycle, first thing is we have the lowering with the rotating updraft, the wall cloud, which is starting to develop right in this area here. So here's our lowering. After a while, that same storm, we notice a clearing area in here. That's downward moving air, called the rear flank downdraft. Don't worry about trying to remember that term. Those of you that have been in spotter training before have heard that, used that term many times, I'm sure. But it's downward moving air, and that's why it's a little brighter here, because the clouds have cleared out. They're drying out in that area. But you still have your wall cloud. We have a funnel that's developed. So now that means our rotation is tightening up. It's not quite as wide across, it's narrow, and so it's spinning faster. And actually, if you were, I definitely don't advise this, but if you were standing like right underneath all that, what you would notice is kind of like this horseshoe kind of look in the sky, going around, and the northern end of that horseshoe is where you would have this this wall cloud and the funnel cloud here. And then your drying air moving down over here, the rear flank downdraft when it comes down is what's going to get your tornado to develop. Here's another example of a storm. This is a completely separate storm. Very wide wall cloud. In fact, the right side of the wall cloud's out of the picture here, zoomed in. Very distinct funnel. But the thing to point out here is when a tornado first forms, I want you to remember, don't treat a tornado as a solid object, okay? It's wind. It's wind rotating around a vertical axis, okay, connected to the bottom of the thunderstorm. And just like on any windy day, you're not going to see the wind until it starts picking up some debris. Same thing with a tornado. When it's first forming, when it develops near the ground, you're not going to see any visual indication that there's a tornado until it starts picking up some debris, and then once it starts moving up into the updraft, then it cools, condenses, and then you get that full cloud. You get that full funnel, the tornado, to develop. And a moment after that picture, 2 minutes later, you can see under the funnel is lowering, but now we have debris directly underneath it. That is the beginning of the tornado right there when you see that debris. So if you see that debris underneath a wall cloud or underneath a funnel cloud, report that. Report that as a developing tornado, and then continue to watch it for development as it fills in. Here's the mature stage. You can kind of see here that kind of horseshoe shape again. Southern portion of the horseshoe here, northern portion up in here. Here's your very wide, your mesocyclone with your wall cloud, your whole tornado in there. The thing that some spotters will do is when they lose sight of the tornado itself and they see lots of debris, they will sometimes report that the tornado is dissipating. It's not dissipating, it's probably still in contact with the ground because of all that debris that you see. Eventually the tornado will dissipate, and like I said, they all have different life cycles. Some of them can only be around for a minute, 30 seconds or less. Others will track 50 miles. But they all end the same way. They're all going to end with this rope stage, which is the tornado now has very little upward motion in it. A lot of it is downward motion, so that rotation now shrinks even smaller, and as it does, it just eventually wraps up and disappears, and you still have some of the residual debris from the storm, but you don't see any connection with the storm any longer. The one thing though that a lot of these classic supercells do though is they persist. They keep producing tornadoes one after the other. We call those cyclic supercells. A lot of them are like this. Once in a while we'll see one nice classic supercell produce one tornado and then it show's over, it's done. But several of these will produce families of tornadoes. Like in this case here, we have a tornado moving along. The thing here is that it's starting to get a little more narrow toward the ground level. We're starting to see lowering over here off to the east. A lot of times, and again, if these are moving to the east or northeast, it's in that direction, usually in the easterly direction where the next one is going to form. And sure enough, we see old tornado starting to get thinner, and the new tornado is just starting to form off to the east. I'm going to show you a video here in a moment, and the key of this video is that you have to keep an eye on everything around you, especially if the tornado is near. I mean, you don't want to be too near these things, that's a safety thing, but you have to kind of keep your head on a swivel, because you got to look all around for things that are developing or could be developing around you, and that's what happens in this case.
He said he would now that when it's for Texas.
Hey, I ain't got time. I'm shooting good video, good steady video.
I heard that roar. Did you get that cow?
Yes.
Oh God, is that another one over to the east?
Where?
I mean to the west?
MID. Got the whole sky rotating above me. We gotta get east. It's moving south. I'm on the door.
Yeah, we always tell people, don't spot by yourself, and when you are spotting with somebody else, listen to them, or they'll lock you out of the car. Especially if it's your wife or your girlfriend. So there's the key, is that the guy, he's filming, getting that good video, but doesn't realize that right near where they are, another one is starting to develop. The one he's recording is starting to die out, and another one is forming. You have to look all around you for these things as they develop. The high precipitation supercells. Again, a lot of the same features we have here. Mesocyclone with the banded clouds here, your tilted updraft through here, but you got this heavy precipitation in here. Here's a time-lapse video here showing the tail cloud on the right side of the image, right here, very prominent. You got your banded clouds here. You can make out this, and again, this is time-lapse, but you can see the left to right motion. If there's anything that's going to develop tornado-wise, very likely it's going to occur in that area that's on the other side of the rain over there, and it's going to be very difficult to make out from that location. Now, I will say that being in this location is good. This is safe because, you know, again, with a storm moving towards some easterly, you know, east or northeast, you're well to the south of the storm. Several miles away, you're watching this storm. You see the band of cloud here, and you got a little bit of a tail cloud trying to form here, and you have all this, you know, inflow here, but you got this rain wrapping around over here. So if you're going to actually see what's going on, unfortunately, you know, you're going to put yourself in a very bad position. So don't do that, okay? But I know this guy, Roger Edwards, he works at the Storm Prediction Center, really good storm chaser, and he got out ahead of an HP Supercell, and you can see the lowering here. So it's kind of a wide funnel at this point. This did end up producing a tornado. You know, if you just ignore the part on the left side for now, this looks like a classic supercell. But the problem is you got all this rain that's wrapping around the southwest and eventually the south side. If you can see the rotation and you have rain occurring on the right, rain occurring on the left, and that's in the middle, that sucker's heading right toward you. And you need to you got to get out of there quickly. Go east as fast as you can, go south. That's why we don't want you to get too close to these storms. Again, we're not encouraging anybody to go, you know, following after these storms. It's just as good and we get just as good information from spotters who are spotting from their home or where they work, wherever they spend time. Okay, we're not saying you have to go out and follow these things because it can be very, very dangerous to do. Here's a radar indication of a high precipitation supercell. This is kind of like a textbook case of a high precipitation supercell. This front notch, this part right here where there's very little rain, the air is flowing into there. This is where your rotation is here. Again, if you look at this, it almost looks like a classic supercell here, except you have this rain, a lot of rain off to the south and the western part of the storm, all kind of wrapping around like this. It may even kind of completely come around there. And if you're going to get a tornado, it's going to be kind of tucked in right in this area right here. Yeah, where I got the yellow circle there, that's where your rotating updraft can be. That's where it usually is. Not all the time. This is the storm just before it approached Gifford. If you would just look at this radar image here, you'd say, oh, okay, you know, we got the notch on the front end. That's where I would put the mesocyclone. That's probably where the rotation is. Here's, you know, your rain wrapping around. But you got to be careful with that because when we actually look at the velocity image, the mesocyclone is actually back here more. More of the rain, and I kind of cheated with this one because if I would have showed you several minutes before that, it would have had more of that notch kind of look like I showed you in the previous slide. But what happened with this case is before it got to Gifford, and Gifford is it? Yeah, right there. This is Gifford. This is right as the tornado is approaching. Is when that rain had just like completely wrapped around the rotation. And the tornado was already there. I mean, the tornado had developed not far from Thomasboro and moved off to the northeast. This was another one, I think, if I'm not mistaken, that tornado was on the ground like 29 miles. It went up into Vermilion County before it dissipated. At any rate, you got to be careful looking at radar. Use all the available resources to you. All right, we're ready to take a break here, but just a couple more slides that I want to show you. Tornado-like rotations, we're going to call these. Gustnadoes are short-lived rotations along a gust front or an outflow. This is an outflow. This thin blue and a little bit of green in that line, That's marking the cooler, denser air from the rain that was up north of Peoria, north of Bloomington, and the warm, more humid air to the south. And it's almost like a miniature front, basically. It's like a miniature cold front. You can not only get new storms developing along those in the right conditions, but you can get these, what's called Gustnadoes. Here's an example of what a gustnado looks like. Essentially what it is the outflow, the air that's pushing out from where that rain was, has some wind with it, and if it picks up some debris in the field, the fast-moving nature of that air will start spinning very rapidly. But the thing to notice here is that this rotation is not connected to the bottom of the storm, or the leading cloud here. So that's not a tornado, okay? This is just one of those things that develops because, frankly, we live on a planet that rotates, okay? And we get rotations that develop. Same thing, it's just because of speed. You can see these if it's dry and you're going down, a county road, and let's say you're behind a semi-truck that's moving pretty quick. This truck moves through and you see these little swirls on the side of the road, okay? Picking up the dirt and debris. That's what's going on here. It's the wind that's pushing, a little highly concentrated wind. In fact, you can see here how the wind is picking up some of the dirt and debris, and it spins up quickly. They can cause some minor damage, but it's not because of the spinning, it's because of the wind itself that created it. But report a gustnado if you see something like that, not a tornado. And then cold air funnels. Cold air funnels occur in vertically developed clouds, usually without thunder. Usually these will occur in the afternoons, the day after we've had storms or severe weather. Very common in late spring into early summer, and again in the fall. In fact, I think we still got Pete's picture here. Pete's sitting right in the front row here. We need a new cold air funnel picture from you. So if you get one, send one along. But yeah, arrange that. But these rarely reach the ground. We had quite a few of these last summer. Some of them weren't truly cold air funnels, but we had several days in a row where they were. Every afternoon we were getting funnel cloud reports. These are going to occur. This is something that does occur because of the heating. And you're getting the rising thermals, the air forming, and or rising up, getting the clouds to form, and then you get little skinny ones of those. We saw something like that very similar this afternoon. Somebody posted a picture on Twitter this afternoon of a very skinny funnel. It was near the warm front, and it pulled some of the horizontally rotating air near the warm front and stretched it up and got a little skinny funnel. These are not associated with thunderstorms, these cold air funnels. You might get a little rain shower out of them sometimes, but more often than not, it's just a bunch of gray clouds. Okay, so we are going to take a break. Before we go on a break, here, just want to mention very quickly, for those of you, we encourage you to be volunteers for your local emergency management agency. John you could probably always use volunteers. So if you're interested in being an EMA volunteer, please see John Dwyer over here. If you would like to be a Skywarn spotter, which means you'd be reporting directly to us at the National Weather Service, but we're always in radio contact with John through our Starcom radio. So anything we get, we would report directly to him anyway. But if you want to be one of those spotters, we've got some forms here. You have to be at least 18 to be considered officially a spotter. We just fill one of these out. We just need some basic information. We don't share any of that information with anybody. It's just for our use, so when you call, we know we can identify you. If you've already filled one of these out already in the past, or maybe you had a spotter ID number associated with it, we're not doing the ID numbers anymore, but the only reason you'd need to fill out one of these again is if your information changed, like you moved, or you have a new email, or a new phone number, something like that. All right, the second portion, we're going to start out talking about some of the challenges that spotters face because, as it says here, it's not always going to be easy out there. You're going to see some things that you're going to wonder, what in the heck am I looking at? Or is that a funnel cloud really? Or am I looking at low-hanging clouds? Or it happens in every severe weather event, even non-severe weather events. So we'll talk about some of these things. We're going to spend quite a bit of time in this section here, guidelines for spotters. A lot of this is some of it's review, but a lot of it's some newer way of presenting things that we haven't done before, because we got feedback from spotters like you guys and gals and said, where can we get some of these resources? Where can I find out what you guys are talking about as far as, should we expect tornadoes? Are we going to have hail? What type of storms are we going to have? When should I be looking to be activated as a spotter? That type of thing. So we'll cover that. And then we'll finish up with severe weather reporting. Very important, because you don't want to keep it to yourself. You got to tell somebody what's going on if you have noticed something that is severe. So first of all, the challenges for spotters. Distance can be an issue. We have a really nice formed storm here, funnel cloud extending darn near to the ground. But remember, to be a tornado, it has to be in contact with the ground, so it's a rotation about a vertical axis that is in connection with the storm and touching the ground. When you're at a distance, which is good for safety reasons, you want to be at a distance, but you might not always be able to see very well. So we always recommend bring along a pair of binoculars, have some way that you can look off into the distance. So, let's say if we had our binoculars and zoomed in there, at this moment we would see, we remember again from spotter training, that we have to have a connection with the ground, and usually when a tornado first develops, we're going to see that debris starting to get raised. At this exact moment that this photo is taken, we don't see that, okay? So technically at the moment we have a funnel cloud. However, if you got a funnel cloud hanging that low to the ground, that thing most likely, many, many times, is going to become a tornado. You're going to have contact with the ground. So if you saw that at that moment, report a funnel cloud, but the thing is, keep watching it and keep reporting as the situation changes. We like to hear back from spotters several times, giving us updates, what's going on. Okay, here's a video. So here's the same question. Is this a tornado or is this a funnel cloud? Well, for one thing, a lot of trees. We're in a moving vehicle, kind of coming around a winding road area, going up a hill, and then all of a sudden get to the other side of the tree, and there's the tornado right there. So for the first few seconds there, the trees and the terrain and the winding road kind of blocks the view of the tornado. The tornado, you got to obviously see the debris, it's rotating around there. Didn't have that classic connection to that funnel cloud quite at that moment, but it is a tornado. It's in contact with the ground. There is debris, so it's causing even some minor damage to trees. So the point here is you have to be extremely careful when you're on curvy roads, winding roads, any type of terrain, trees around. The obstructions can really be a problem. That can be a big challenge for spotters. These you're going to see all the time, these scud clouds, or we like to call them scary looking clouds. In fact, my counterpart up at the Milwaukee National Weather Service, he's got a thing called the Scary Looking Cloud Club, where his spotters will send pictures. I would love to do that here. Send me your pictures of your scary looking clouds and I'll put them in the spotter class so I don't have to use all these examples from Wisconsin. But, I'm from Wisconsin, so I'm not bashing it. But the scud clouds, these things can often take shapes of features that we talk about in spotter training: wall clouds, funnel clouds. Sometimes it even looks like a developing tornado. There's going to be a lot of this because storms, one of the ingredients to get a thunderstorm is moisture. And when you have so much moisture available, you're going to have a lot of these low-hanging clouds. Even behind the storms, as I was driving here to teach this class today, I saw a lot of low-hanging clouds hanging around on the back side of the, west side of the storms as they were moving off or had already moved off. So you're going to see a lot of this stuff. Here's an example. This is a low-hanging cloud here that could look like, do we have a developing funnel cloud over here? We got another one here. More typical of what you're going to see, it's not connected to anything, but I could see somebody going, oh, that could be a developing tornado. Mainly not trained spotters, because you guys know that these are scud clouds, or you'll know after tonight. But a lot of people will report this kind of thing. That one there, I mean, yeah, that looks like and this was a Wisconsin picture, of it looks like a funnel cloud. But you can barely see where this is the cloud right here. It's not connected to anything. The key here is you'll see these things moving along independently of the storm. They're not connected to anything, no rotation. Just watch them. If you're not sure, think, well, maybe that really is a funnel cloud. Watch it, keep your eyes on it. Don't be so quick to report. We want the reports quickly, but take your time so you're reporting accurately, okay? The other thing I point out is I've been telling this to all the classes I've been teaching. I have a lot of these pictures like this. If anybody has any video of scud clouds like this, send them to me and I'll use it. I know who wants to stand there and take video of scud clouds, right? I mean, you want to take funnels and tornadoes and all that. But I think it would help to identify that, hey, look at these clouds, look how they're moving, they're not connected to anything. Another great example, I wish I had a video of this. Here you got so many low-hanging clouds here. That even looks like a wall cloud there. It even looks like it's connected to the rest of the storm. It's not. They're all just kind of moving along below the storm. But again, keep your eyes on these types of things because you're going to see a ton of this stuff when you're out spotting. Rain shafts. Here's another thing we see a lot of, virga and rain shafts. This happened to be both. This is a series of pictures from around Bloomington Normal last year. Very shallow clouds. Below the cloud, it was extremely dry. So we had rain showers falling through the atmosphere here, but it was barely hit, none of it was really hitting the ground, or if it was just a sprinkle here and there because the atmosphere was so dry it was evaporating. And so here we have virga here, and then it eventually, as it moistened up, that virga turned into a rain shaft. And if you weren't looking, let's say you were off looking in this direction at whatever, and you turned around and saw that, you'd be, oh my God, it's a white tornado, because look at that. But that was a shaft of heavy rain that got through there. And then same thing there, it just widened as the atmosphere kept moistening, and it's raining on the wind farm here. So especially at night, oftentimes, or as we're getting closer to, I should say, as we get close to dusk, when it gets backlit, sometimes these can appear very dark looking, and they really do look like tornadoes sometimes. So you got to be really careful with these. But again, the key thing here is know the environment. Look at the radar, if you have radar available to you. And then just look at, if that was a tornado, we'd be seeing all sorts of debris around here, lifted up and upward motion. And this is all down, this would be all downward motion because it's from rain coming down. So just look at the motions of the features that are available to you. All right, some guidelines for spotters. We're going to talk about being prepared, about being aware, situational awareness, but also safety guidelines. So we want to talk about what we're calling the spotter funnel of awareness. Starting out at the top with seasonal looks at what you can do during different seasons of the year, all the way down to that day you're having severe weather and warnings are being issued. So let's start out with season. On a seasonal basis, what you can do is, number one, know the climatology, what time of year severe weather is favorable, but also be prepared to, gather your supplies for storm spotting, but also train, review, and we'll talk about where you can get some of this information to do that. So first of all, when it comes to climatology, got this really neat video from the Storm Prediction Center showing the daily chances of severe weather, so tornado, thunderstorm, wind gusts, damage or hail, within 25 miles of a point. And we can see as the year goes on how it changes. And I'll let this play through here a couple times. You can see how when it starts over here in the beginning of the year, it's primarily in the southern United States, near the Gulf Coast, and then expands unless it's 2017, then it expands to Illinois in February, like it did this year. That's fun. Everything is about 3 weeks ahead of this year. The only thing I don't like about this is, and I understand what they're saying with the statistics, but I don't want to give you the impression that we don't get severe weather in October or November or December. A couple things I want to share with you here regarding that. Number one, people often ask me, well, what's our severe weather season in Illinois? And I tell them it's January to December. Okay, it really is, because we can get severe weather any time of the year. You have to be prepared all year long. So that's one thing. The other thing is when we look back at the stats, and it's a very small sample, but we're just looking at the last 6 or 7 years, almost 50% of all of our tornadoes in Illinois have occurred during the cool season. And when I say the cool season, I mean October, November, December, January, February, March. Almost 50% in the last 7 years. We've had some big outbreaks. I already mentioned February 28th of this year, okay? 15 tornadoes in Illinois on February 28th. November of 2017, 25 tornadoes. We had tornadoes around Petersburg on New Year's Eve in 2010. Okay, 1 year, recently within the last 10 years, we were in tornado watch #1 in the state of Illinois. And that was including northern Illinois and part of southern Wisconsin. So the thing is we need to be ready all year long. Even though our peak tornado season, is typically April, May, and June, we never have a time where we haven't had tornadoes. We're seeing these numbers go up. I mean, the February numbers don't include what happened this year. This is through last year. So I'm going to have to add 15 to that. We'll be up to 63 tornadoes in February. Look at the November numbers. The last few years have gone up. We have just as many tornadoes in November as we've had in September. We had more tornadoes in December than October. So the point here is when you get these fall and especially winter days when it's warm, when it's kind of humid, we tend to have a stronger jet stream over us. It's very spring-like. And when you have that set up, you're getting your ingredients for severe weather, for these big outbreaks of severe weather, for the long track tornadoes, for the high wind gusts, for the big hail. So it's not just April, May, and June. In fact, the last few years we've had hardly, I better knock on wood when I say this, but April has had very little severe weather the last few years. Here's our graph for severe wind and large hail, wind being in the blue, hail in that kind of magenta color. Wind typically peaks in June and July, but again, we can get it any time of the year. But we get a whole lot of reports in the state of Illinois. This goes back to 1984, so we're looking at about 33 years here. And it peaks pretty much during the summer, where the hail, your ingredients for large hail is primarily a springtime thing. We can get big hail with the big storms in July and August. It's just not as common. Another thing that kind of surprised me, lightning density. Spotters face a lot, and anybody who's out in storms, you face a lot of lightning. Illinois ranks 8th in the country for the most lightning strikes per square mile every single year. Florida is #1. That's no surprise whatsoever. But number 8 up here, that kind of surprised me until I saw the data. So we do get a lot of lightning up here that we have to be very careful about. So we'll spend some time talking about lightning safety. So there's our climatology for weather. I'm going to be talking about, since I'm with the National Weather Service, I'm going to be talking about our webpage. But we have a lot of resources on here. In fact, there's really only 2 sections of our webpage that I'm going to point out to you that you can go to for either updating your training or for getting, like on a day like today, hey, are we in a slight, enhanced risk, moderate risk, what are we in, when can we expect severe weather, that type of thing. So I'll point those out to you here in the coming moments. But I zoomed in here on the lower part of our webpage, at the very bottom of our webpage under observer information, it says Skywarn Network. That's where you can find out information about spotter training. Maybe some of you saw that, went to that page to find out about the class tonight. We also have an online spotter class that you can take through our partners at Comet, the Comet Meteorological Education, MEDED. they have a good spotter class on there. It's 2 sections, about 45 to 60 minutes to get through each section, and you can print out a certificate when you're done. But it's a good refresher training as well. And we have a review of topics on our spotter page as well. This spotter class here, I mean not this exact one here in Champaign County, but what we're teaching here, we're going to create some YouTube videos, and about 5 minutes long, broken up into about 12, 13 different segments to go through all this training. So if you want a review on supercells, or you want to look back on squall lines or whatever, you can do that and just catch this quick little 5-6 minute video. We'll have that available next month. We have one on there already from the spotter training 2 years ago. The content is pretty much the same, or at least the concepts are the same, I should say. Okay, another thing you can do ahead of time, you can use this, or you can use mapping programs, online mapping programs, to determine what's around you. So let's say you're spotting from home and you look out and you go, you know, there's always that water tower in the distance, or those power lines, or that row of trees. How far away is that? Because if you were to see a tornado develop there, or you were to see a rain shaft in that area or whatever, you know, how far away is that? It's really hard to judge distance. What we find out is when people say, hey, I see something that's this many miles away, and then we actually measure it out, we find out that it's usually twice as far away as what people think. People will say, oh, you know, it's 2 miles away, when actually it's like 5 miles away, okay? So you can help that by looking at different landmarks around you, where you live, where you work, and you can use mapping programs to figure that out and just measure how far away that is. So those are some things you can do ahead of time. So now we're getting into our outlook for severe weather. Let's say we're within a 1 to 5 day time frame now. Sometimes we can go beyond that. I know when we had the November 17th tornadoes, we were looking at that about a week ahead of time. And even 5 days ahead of time, we were saying, yeah, Sunday, November 17th, east of the Illinois River, late morning. And the models, our forecast models just kept showing the same thing over and over. We had very high confidence. So sometimes we can get a real good outlook. But several days in the future, outlooks. That's giving you as spotters heads up. Okay, prepare. We want our most effective spotters, and if you want to be an effective spotter, you need to anticipate. Okay, we want you to anticipate what kind of storms, when spotters might have to activate, what are the main components of that storm. Is it a day for tornadoes? Is it a day for straight line winds? Downbursts. Are we looking for large hail? Is this mainly going to be a flash flood situation? What are we dealing with? The best way to get that information, again, on the lowest part of our webpage under hazardous weather, we do have a spotter briefing page here, but you know what? Actually, we have a new page here that I like a lot better. It's called decision support, because we put more information on that webpage. Go to that decision support page, and I'm going to show you a number of things that you can get on there. The very first thing you're going to see on that web page, and the web address is on the handout here. Hopefully you got one of those at the break, and if you didn't, come up and get one afterward. The daily decision support briefing, the DSS briefing. This is something that we create every day, and we send to our partners in emergency management. And I know that a lot of them will then share that as does within their community, within their county. If they're not, let me know and I'll say, hey, you need to send it to those folks. But there's a lot of good information in there, because we're going to highlight over the next 7 days what you can expect for severe storms or winter storms or whatever, flooding. We also have a weather story on there, which is right next. It's kind of hard to see at the very bottom, but it's right here. You click on that, and then in the big pane up here, you'll see the weather story. We also have a link to that on our main web page. That's just kind of a one graphic showing you, here's what we're expecting. The one we had on there for today talked about, you know, when we were expecting the severe weather, that we were expecting mainly wind and some hail. There could be an isolated tornado, but mainly wind and hail. So if you want some more detailed information, on the lower right there in weather briefing information is the Storm Prediction Center outlooks right here. That's for the whole country, and then we have one that's just zoomed in on the state of Illinois. The Storm Prediction Center outlooks are listed in 6 different categories. There's a light green, which is basic thunderstorms. General thunderstorms, no severe weather. So state of Illinois in this example would be general thunderstorms. The marginal, which is in the southern part of Kansas or even parts of Washington, Oregon, in this example, means there could be an isolated severe storm that might put out some large hail. We might get some wind gusts up to 60 miles per hour, maybe a tornado, but really very marginal, very little severe weather is anticipated. Then there's the slight risk, which is scattered severe storms. There's going to be severe weather and a slight risk, but they'll be scattered about. It's not going to be concentrated or a widespread outbreak by any means. This particular example, an enhanced risk, a large part of east central and southern Illinois today was in the enhanced risk. This means numerous severe storms possible. There could be a few tornadoes, but more likely several reports of wind damage and some large hail. The slight and the enhanced, we see several of these as we go through the spring and summer months, particularly throughout the year. The moderate and high risk, these are the big ones. Storm Prediction Center reserves these for the big outbreaks. Moderate risk, widespread severe storms likely. February 28th of this year was a moderate risk in a large part of northern and central Illinois. Actually, I think a large part of the state. They ended up including a lot of southern Illinois too. But strong tornadoes, widespread wind damage, large hail, you're going to have supercells on a day when you have a moderate risk, or an extended period, extended length of squall line moving across. We call that a derecho. Can also have a moderate risk associated with it. And then high risk. The last time we had a high risk around here, again, knock on wood, November 17th, 2013 was a high risk day. That's the last time we had a high risk here, I believe. This example was from the April 2011, April 27th, 2011, when they had the devastating tornadoes in Tuscaloosa, Birmingham, Alabama, parts of Mississippi and Tennessee. High risk means it's all or nothing. I mean, if the atmosphere breaks, you have all the ingredients. You've got instability, you've got high winds, you've got plenty of moisture, you're gonna have massive tornado outbreaks. Think about the Joplin tornado day too. Those are, you're talking high risk type situations there. So widespread severe weather. And if you forget, is moderate greater than enhanced, or enhanced slight less than, it's kind of sometimes hard to remember all that. Storm Prediction Center has a legend on every map they put out like that, and it's number coded. So general thunderstorm, and then you've got 1, 2, 3, 4, 5, the highest number being number 5, the highest risk level. So just take a look at the numbers there if you forget the categories, how they line up. Another thing, if you scroll a little bit farther down on that same decision support page under text products, I'm pointing to the first green one here, hazardous weather outlook. This is the one, and you have to look at the counties up here because this will be broken up. We might have 3 or 4 different sections because we cover 35 counties in central and southeast Illinois. So find your county, and then it will tell you day 1, this afternoon and tonight. In this case, strong to severe storms expected, etc. We're talking about primary threat damaging winds. Could produce some hail. We might get an isolated tornado. I want to key in on the spotter information statement though. That's the last thing we put in there. This is where, as a spotter, use that information because we're saying, like in this example, between 3 and 8 p.m. This is when we're going to need spotters. Today, the hazardous weather outlook we put out, actually the one we put out yesterday and the one again we put out this morning, said spotters likely would be needed between noon and 6 p.m. So we're trying to narrow that down into a 4, 5, 6 hour window as to when spotters may need to be activated within that area. So that's a good thing to check. Maybe if it's not the day of severe storms, but days leading up. Check those things out. Keep updated with that. When it comes to now we're into the watch. And as spotters, you absolutely have to know the difference between a watch and a warning, okay? A lot of the public gets these confused, the two W words. Watch, we're telling people, keep your eyes to the sky, okay? Watch, all right? It's not like I'm telling you, like you would tell a little kid, you know, I'm warning you, put that down, or leave that alone, or whatever, okay? We're not warning you, go to your basement. We're saying watch, keep an eye out. So when a watch is issued, now we're talking a time frame of several hours. 6 hours, 8, sometimes 10 hours in extreme cases. Keep an eye out in your area if you are in that watch for severe thunderstorms or the watch for tornado. Same page, decision support page. This is not a different page. It's just that we have something called a graphical nowcast, graphical short-term forecast. During severe weather, we issue these hourly. And a lot of times it will show on there, we'll put the radar, like in this case here, this is an actual one we had from last year. Line of storms approaching. The pink here was showing where the watch was. We had a severe thunderstorm watch that day till 9 o'clock. And here's what we're expecting: hail, wind, lightning, okay? So that day, the atmosphere was not conducive to tornadoes. But if we're expecting tornadoes, then we'll have it listed there. So it gives you an idea of what to anticipate during that watch. We're going to tell you here, you know, like here, the line of storms is moving east, 35 miles an hour. So you get an idea how fast those storms are moving and where we expect over the next hour or so severe storms may develop. So it'll be listed in that product right there. So you can use that during the watch to keep yourself updated. Also, we have a tab right here for radar and satellite. Again, you know, if you don't have a radar app, you can use the radar on our webpage and take a look at that to follow the storms as they're approaching your area. If you want more detailed information about the severe thunderstorm watch or the tornado watch, go to the Storm Prediction Center page. Just play around on their webpage. They've got a ton of stuff on there. If you're interested in severe weather, you're going to find all kinds of stuff on there. And they have a lot of these FAQs, frequently asked question things. So you can learn little question marks. Click on the question mark. It'll show you what does that mean. You know, like one of these, so what's this stretching potential term? What the heck does that mean? You know, click on it and it'll tell you what that means. So there's a lot of different stuff on their webpage. But the watches you can check out with that web address there. Other things. This is stuff, you know, you want to make sure you've got all these things and in a good working order during the seasonal portion, but during a watch, this is when you go on and gather your stuff and say, okay, you know, I might have to be activated here, or if I might have to just, you know, look out the front door and see what's going on. Have a way to communicate what you're seeing, whether it's if you're a ham radio operator, using your cell phone, whatever you're using. Have your GPS or your location turned on your device. I mentioned the binoculars already. It's good to have. Weather radio, you never go wrong having one of those, especially a mobile one in your back pocket. Key right here, safe shelter. If you're at home, okay, you're probably going to know this is where I would go if a tornado were to approach or if the weather was about to turn bad on me. But what if you're in an area you're not familiar with? Just keep an eye out. Okay, I'm one of these people that everywhere I go, especially if there's bad weather, usually I'm at the weather service doing warnings. But if I'm off, I'm going to look around and I'm going to say, okay, where could I take shelter if there was bad weather? Okay, this is a good facility in here. I wouldn't necessarily want to be in this room, a little bit of a wide, you know, roof span here. But bathrooms are always a good option, hallways on the lowest floor of any type of structure. Basement is the best if you have it. You know, in fact, I keep going back to November 17, 2013. We did a lot of interviews saying, okay, EF4 tornado in Washington, EF3 tornado in Gifford. There were only 3 fatalities. And I don't want to minimize 3 fatalities, but they compared it to Joplin, where there were 160. And I said, you know, one of the differences was not a lot of people in Joplin have basements. Some do, most do not. Here, we're fortunate here in the Midwest because of the type of soil we have. Most homes have them. And if you don't, you know, there's somebody you know or somewhere you can go where there is one available. So that's why a lot of people in Washington were saved, because they were able to go into their basements. But having that safe shelter and having that clear path available to you can help. Definitely help. You have to have a clear path. So for all spotters, again, indoors, get to the lowest level. If you're mobile, okay, and again, I'm not saying go out and follow storms, but if you are mobile, make sure you know the roads. Okay, don't get caught on dead-end roads. All right, don't get into areas that you're not familiar. Some areas, you got to some areas in Kansas and you're chasing, you could end up in an area where it's gravel or dirt, which is now mud, and you could end up getting stuck. So you need to know the roads, where the good roads are, and also where your four-way intersections are. Another thing I would recommend, again, a little further down on our text product page, check out the local storm reports. Every time we get a report from a storm spotter, if it's hail the size of a penny, so 3/4 inch roughly or larger, winds, and sometimes we'll drop it down to 50 miles an hour, but if it's 55, 60 miles per hour or higher, or any type of wind damage, tornadoes and funnel clouds, we will issue a local storm report with that. Now, if I get 18 reports of golf ball size hail, I'm not going to put out 18, from the same city. We'll just put the one out. But what it does is it gives people an idea of what's occurring in their area. Check those out, because look at the storms as they're approaching your area. I like to say use this 2 to 3 county rule. So if you're here in Champaign County, look off to the, where the storm's coming from. Oh, they're coming from the southwest. Look back toward Decatur, even Springfield if you want, and see what's the history of that storm. What's it been doing? Has it been producing large hail? Is it producing wind damage? Have they had multiple tornadoes? Go ahead and check that out. You can also check that out graphically. I don't like to, read through a whole bunch of stuff. I like to look at pictures. So graphically, go to the Storm Prediction Center webpage and see where the reports are coming from. This was March 6th, so this is just like, 3.5 weeks ago. Look at all the tornado reports around the Midwest, and those are the red triangles on here. The blue is the wind reports, and the green are the large hail reports. So you can see, you can follow those as they're being reported and get a storm history. The last part of the funnel is now we're getting into the warning time frame. We're not talking about hours anymore. Now we're talking about minutes, 30 to 60 minutes generally. And this is where your safety has to come in, your safety rules, but also reporting, what to report and who to report to. Some key things to point out here. Your tornado warnings, severe thunderstorm warnings are at the top of our text listing here. You'll get the most recent ones by clicking there. But I want to point out here the severe weather statement. This is probably one of the, unless you're really into the products that we issue at the National Weather Service, this is probably one of the best kept secrets, is the severe weather statement. You gotta take a look at this. Why? Because the severe weather statement is the update to the severe thunderstorm warning and the tornado warning. We issue that one warning. It's going to be out for 30 minutes or 45 minutes or 60 minutes, okay? We're going to update that in 10-minute intervals, 15-minute intervals with the severe weather statement. Some people are like, oh, you issue the warning and you just drop it. You're not even updating it. Yes, we are. We're doing it through the severe weather statement. So take a look at those for updates. Here's an example. It might be kind of hard to see the words here, but it's telling you, it's laid out a lot like the warning. The hazard, 60-mile-an-hour winds reported by trained spotters. You can expect damage to roofs and siding and trees. And then we got a report here. Trained spotters reported power poles down near Tolono, July 13th last year. So another example from Champaign County. We'll also have the, what interstates in between these mile markers and all the towns in the path of that storm that remain. If we start chipping away at the warning because it's moved on through, it'll say there, cancel, the warning has been canceled for this part of the county. So that's kind of like you're clearing, saying, okay, that area has been cleared from the warning. All that's in the severe weather statement. So look at those. So in the warning mode, so now we're in warning mode. You're out there. Let's say you're a mobile spotter. Again, I already mentioned, don't get trapped on dead-end roads. Don't go spotting alone. You're going to want to look at what's going on but you also have to drive. So don't drive and look at the same time. That could really be a problem. And I already mentioned, what happened recently. So don't spot alone. Be aware of traffic congestion, construction areas. Avoid the underpasses. Those are very dangerous if you got a tornado coming through.